Time to have a look at our more complex language for river flows and how that's going to work as a parser. So it's probably worth watching the previous video as well, although I actually think this one might be a bit more compact because we have to do less things to make this one work. So I've got my Devlin's Creek system with Mars Creek and Joe's Creek here on the right, and I've left my little red marks showing me the various places where I might need to calculate things. Oh, there's another one here because there's a computation for the top end of each of those creeks, right? And under this slightly more, well, substantially more powerful modeling technique, I've decided that water doesn't just appear from 1 mil of rain, doesn't all of a sudden just appear through all the river systems. It slowly gets into the river system, and then I also want to model the fact that rivers are downstream from each other, which I haven't done at this point. I haven't done in the other one. So if we just start with Joe's Creek, I'm going to bring up my example file, so I'm using the same, oh, there's no one there. So I'm using the same numbers. I'm going to say that Joe's Creek, I don't like that having a 1 there. Let's make that a 4. I'm just picking these numbers, remember, to try and match what the real situation was. If I was a water modeler, I'd have to make sure I got the exact right numbers by going out into the field, but we're not doing that. We're just modeling. So I said that Joe's Creek, at this point here, the flow after 1 millimeter of rain can be described as 1 spread over 1 at 4 megaliters per second, liters per second. So that's saying that in total, 4 liters per second of flow. The first day is the day with the most rain, and there's a spread of 1 day. The first day is the day where most of the water gets from the ground into the creek, and there's a spread of 1 day for that. So there'll be some on day 0, so there'll be some on day 1 and some on day 2, and then by the time you get to day 3, it's all in the river. All right, so for Mars Creek, I chose 1.5 spread 0 at, oh no, I got those the wrong way around. Ha! I mixed them up. We'll just do that. At 0 at 1. So this should be the other way around because these aren't really a good representation. Mars Creek's bigger than Joe's Creek, but in this one I'm saying that the bulk of the rain falls on days 1 and 2. Sorry, the bulk of the water gets out of the ground on days 1 and 2. There's no spread, so it all comes on days 1 and 2. And the total amount that flows out is 1 liter per second. So what that's going to mean is that on day 1, I'm going to get half a liter per second flow out of Mars Creek. And on day 2, I'm going to get half a liter per second. And on day 3, I'm going to get 0. That's the modeling side of things. But from a language side of things, these are just strings and tokens and stuff that they're just tokens that the scanner's picked up for me. So I've got to go back and think about what my scanner might have done to create these. And I'm going to do the scanner here because we haven't done the scanner in any other piece of code, even though this week's focused on parsing. So if I just think about this example, what should this scan as? Well, we always scan into a list, so I'm reusing my square bracket notation, but this square bracket is Java square bracket, so I'm going to switch to a different pen. So I get a Java list where the first token is one of these square brackets. The second token is a number. The third token is a tilde. I've actually mixed up my notations here because I could have written that as that. But as you'll see in my scanner, I tend to use these capital things for my token types. Then there's another number. Then there's another square brace. Then there's an @ symbol. Then there's another number. Okay, so that's the scan, that's the list of tokens that the scanner should create just for that one thing there. Then I'm going to say that so to get the flow out at this point here, I need to know the flow that happens in the bottom half of Joe's Creek, which in this system I've labeled as 1 tilde 0 at 2. So with that, I now have everything I need to model the flow at this point, and I say that it's the bottom half of the river, 1 tilde 0 at 2, fed by, and I use a backwards arrow for that, that's one of my cool notations, the two creeks above, which just get added together because they just join. They're not up or downstream from each other, they just join. So that's the addition of 1 tilde 1 at 4 plus 1.5 tilde 0 at 1. Okay, so the flow at that part is this fairly long expression, and long enough that I'm not going to try and write the rest of the expression for the full Devlin's Creek, but you can see we've got addition representing creek's confluence coming together, and we've got a left arrow representing a creek being downstream from another point. Cool. So this is a more powerful modeling language, but I've just got to work out how to parse it. So I can already see what the scanner is going to do for each of these tokens, and I also know, I can guess what a scanner is going to do for a plus symbol. I already know that actually. Lox already does that. Lox doesn't have a left arrow symbol, but I reckon I can probably write one. So a job on the scanner, which we might have done in an earlier week, but I'm going to do here, is to get the left arrow, the tilde, and the at into the scanner's output. I think all the others are still in there, or already in there, so I don't have to worry about them. So let's stop and do that now. Let's just make sure the scanner can handle all this. So tilde and at are relatively simple. I jump down to the scanner here, scanner.java. Tilde and at are relatively simple because they are single character tokens. I actually don't have left square bracket or right square bracket here already, so I better put those in as well. So let's do those. And they're just a copy of this, right? It's the exact same thing. I just use square instead of parens. But they've got to scan to a different token, or a different token type, I should say. So I've got to make the left square and the right square for those. And the at works out nice and simple too. That's going to be just like the star, so I'll copy it and put it under there. The at symbol, and it is to a token called at. Now, the squiggles will come up because I don't have those in my token type yet. So I've got to jump over and add them. Over to token type, easy enough. You can see my Copilot making some reasonable decisions there. Again, I'm happy to take the advice of my Copilot, but I'm not going to just do what it says. Syntax error on comma. That doesn't seem right. That should be totally fine to have a comma there. So I'm just going to leave that comma and see if my parser complains about it later. Syntax error, complete class body declaration. Sometimes these in IDE things give me erroneous errors. You might see an error that I can't see yet. If my parser won't accept this, I'll take a look at it later. Actually, I can run the parser right now. So remembering that that's a javac on this particular code base, which I've got in a folder called W6 plus complex. So just compile all the star javas and it's fine. It didn't complain at all. So this is likely just an IDE error on the parse. Maybe I'll chase that up later. So not quite finished with my scanner yet, because I also want the arrow token to come in. But the arrow token is a 2-character token. So it can't be done just like the others. It has to be done like the 2-character tokens. Well, here's the 2-character token, so they're not too hard. Oh, I've already got one that uses the left paren, so that's nice and easy. Here I want to say, well, if you're a left arrow, if the next thing I match is an equal symbol, then spit out a less equal. Otherwise, well, before I was just spitting out less, but now I want to say, if the left thing you spit out is a line, then return left arrow, else less. So I might just put some extra parentheses around there as well. Sorry, that goes like that. If the next thing you matched was that, then question mark. Okay, and left arrow doesn't exist there. Match is not applicable for the argument string because it needs to be a single character, because match only works one character at a time. And let's go put that left arrow in my token types. So it's going to appear down here with some of these. Oh, I've got a rocket there. You'll notice in some of this code, I've worked on this code before for other little things I've put into it. So this rocket might be here from something else. I don't think that's in locks. Okay, so it's happy now with my left arrow there. And if I compile that, it compiles okay. But this is just me getting those tokens into the scanner. Oh, I forgot the tilde. So the tilde is going to work like the @ symbol. It's just a single one and fits just there. Tilde, and back over to token type to put in tilde. Okay, so I'll just try parsing that again. Everything's okay. So now I've got my scanner working to accept this, hopefully. What I'm going to just do is jump back over to my overall locks tool and try out the scanner to see if it works. At the moment, I'm on week 6, so I'm beyond the scanner. So I actually run a parser as well. And my parser is going to fail on these because I haven't written the parser part yet. But hopefully my scanner still works. So to test the new scanner, I am just going to comment those sections out and just system.out. Print line. Look at that. The Copilot's making some sensible suggestions again. I don't want to do it one at a time. I just want to print all the tokens. Thank you, Copilot. Let's see. So compile that again. And now I run that, which is Java, the Java command with the locks, with the file I want to parse. In this case, it's my variant / week 6 locks complex / short / tiny, which is a file I've got up here. So it looks like a 1 tilde at 4. And it seems to have worked. So it's picked up the left square, the number, the tilde, the number, the right square, the null, the at, the number, the end of file, and that. So it's spitting out extra bits and pieces that are in the list, but it's worked. And maybe I'll try it on small as well. That seems to have worked. Then I'll try it on larger. That seems to have worked. And then I'll try it on the full Devlin's example, and that seems to have worked. Okay, so it looks like I got my scanner changes done and dusted. I've got to put my parser changes in now. In this case, again, I'm copying off a week 6 example, which has the full grammar for the week 6 expressions. This is a much simpler expression. Look at that. It's copying it across from my other file because it knows what it looks like. So the Copilot has recognized that I did something similar in another file, and it's just suggesting I do it. And in fact, it's right. The start is right? An expression in this language is just like the other one. It's a mini term, and it could be just a single mini term, which like it is in Tiny. Or it could be a mini term followed by something else, which is probably an operator and then some other mini term. Okay, good. That's what we have here, an operator and a mini term multiple times. But in this case, an operator is not just a plus, because an operator could be a left arrow as well. Either of those could possibly go there. We can see an example here where it's the plus is the one, and here's the one where the left arrow is the one. And then what's a mini term going to be? A mini term is going to be just one of these things, or one of these things, or another expression in parentheses, because I could put a whole parenthesized expression over there. So Copilot's not doing too bad, but a flow doesn't exist in my language as a token. It thinks it does because it did in my other file. And it's realized that, yes, a parenthesized expression is the other thing. And if you go back and do my previous example, you'll see me incorrectly putting parenthesized mini term in there and then not realizing till later that it should be a parenthesized expression. Having done that in one file now, the Copilot is able to point me in that direction instead of pointing me in a different direction. But this flow doesn't exist yet. The flow is the rather complex little literal thing I made before. So I need a parser for that as well. Oh, look, it's going to have a go at it for me. Well, the Copilot's had a pretty bad go at it because that's not what it looks like. It looks like left, paren, and number, and tilde, and now number, and right paren, and at, and number. Okay, so those are my tokens, but generally when I write these in the parser, in this grammar here, I actually just use the strings for really simple tokens. So it looks a bit more like this. Okay, so that's my parser for my shorter form, but that's everything I need. So now all I've got to do is make the expression parsing function work, write myself an op parsing function, write myself a miniterm parsing function, write myself a flow parsing function. So the expression one here, just like before, it doesn't jump to equality like it did in the original, much larger one where there's all these things to worry about. It is, in fact, it is grab me one expression, please, which is going to be some kind of mini term. And then while the next thing is, that was good. While the next thing is either a plus or a left arrow, I don't know that match is the right thing to put there, is it? Oh, it is, yeah. While the next thing is a plus or a left arrow, grab the token, because we've done the match, it's the previous thing, then grab the next mini term and then build ourselves a binary out of that. And we're done. Oh, good. Nice work, Copilot. So that, again, it's copied from the other file, but it was smart enough to realize I needed a left arrow in here potentially as well. And I return expr. So now I need to write this mini term function. Private expression mini term. I'm reading this to see if it's right. If I match a flow, then I return a flow with the previous literal. It's looking ahead for me and doing what I did in my other one. Let's think about it. What do I want? So remembering that a parser has to create an abstract syntax tree. So what's the abstract syntax tree that should be created when I parse one of these flows? So when I parse a number, it creates me a literal node, and it puts the number in there, and it also puts the double in there for me. That's what my parser currently, that's what the LOX parser currently does. So when I'm parsing a flow node, what should it create for me? I think it's going to have to create a relatively complex object that I've asked for. It's probably going to have to create a special object. I might call it a flow, which has a mean, a spread, and a magnitude, which are those three numbers. So I'm going to need this new abstract syntax tree node. And that's what the Copilot was working out, because I did that in my other example. Okay, let's jump over to generate AST and make one of these. Because I've got a literal, I've got unaries and groupings and binaries which LOX used, but I need a flow. Or any new one to look after this, but I decided flow is the right one. And it's got a mean. It's got a, well, there you go. It's got an object. Variance is a better word. I like that one. Count is the wrong word. we'll call it magnitude. And that's that. So we've now got another kind of abstract syntax tree node that might appear in our final abstract syntax tree. That means we've got to rerun the generator. So I've got that up here somewhere. That's the javac, where you rerun not the locks itself, so that's Java. I have to recompile the section that runs the tooling. Then I have to rerun the tooling, which is, I've lost track of it. All right, let's do it. Java variants W6 plus complex tool generate. And when I run that tool, I've got to tell it which directory to put it in. Variants W6 plus complex. That's where it's going to go. And I hit it. Okay, so that's generated my new abstract syntax tree nodes. And look, my AST printer and my parser have immediately gone, well, my parser was unhappy already. My AST printer's immediately gone unhappy because the new generated AST node isn't part of the visitor here in the AST. I don't have a visit flow expression. I've got all the others. So I better put one. Okay, yes, thank you. That's what I want. And if mean equals null, variance equals null, or magnitude equals null, I don't worry about any of those. I'm just going to use the Java's built-in toString for the whole thing, because I'm just cheating for now. We'll look at it later. Return expression.toString. Okay. That's probably going to print out one of these Java object references, but it'll get me started. It's got the AST printer to stop complaining. So now I can come back over and finish the mini term, right? Because I said in my language at the top here that a mini term is, that's a flow or an expression. Actually, I haven't done op yet, have I? Okay, so here operator is just being grabbed as a token, which, that's interesting. Okay, so with the binary, you just put the token in the operator and it looks after it. So the way Locks has done operators means I don't necessarily have to put a new parser in for operator. It's just going to take any of the operators. Interesting. That's interesting. There's always new things to learn. Okay, so miniterm is going to be a flow or a other thing. So that is if, well, let's back up and see what, here we go, that's one. If we match flow for the next token, then, but we don't have a flow token, so that's not right. Okay, this is a little bit tricky for us, isn't it? How can we work out if the next thing we match is a flow or not? Let's look for some inspiration. Is there any example up here where we had to use a parser? So here's one where we tried to parse a number or a string or a true or a false. So let's look for some inspiration down in primary. Okay, so primary said, it went through all the easy ones first. It went through the ones that you can tell straight away and said, okay, do them, otherwise try the other ones. So we can do that. We can say if match left paren, then we must be doing the parenthesized one. So do expression equals expression, consume the right paren. Where did you go? Sometimes the Copilot knows and then forgets when you're halfway through. Consume the right paren and return the new grouping. That's correct. Thank you, Copilot. Else if left square, that means we're doing a flow. So that's not a bad guess by the Copilot, but I could also just say, no, I've got to parse a flow here. So I'm going to try, that's what I'm going to do. I'm just going to say else expr equals flow, or just return flow. Whoops. And the flow parser's got to be written. Now it's going to need me to put an error in here because I don't have a return down there, and the flow is not written, so I better write that. Okay, so we need a left square for the flow. So it's given, the Copilot has suggested that. It's suggested if you match the left square, you're in a flow, otherwise throw an error. That seems reasonable, I'll take that. Now pull in the number, which is consuming a number. Good. And grab the literal out of that token and use it. Don't know that I have a literal out of that token. Then I consume a tilde and complain if I don't have it. Then I consume another number. Then I consume a square bracket, and I consume an @ and I consume another number. And now I've got everything I need to return the new flow. It's got this bit wrong though. So that's not how I return a new flow, because there's no such thing. There's only an expression.flow. I just send the 3 parameters through. Okay, I'm showing you this because it like the Copilot does weird things. You can't just the only reason I know what the Copilot's supposed to do and can fix it is because I know where I'm heading. It's really difficult to actually work with a Copilot if you're not thinking a little bit ahead. So syntax error, insert to complete statement. I thought the statement was complete. Return a new expression. If match square. Okay, and then we got the, if it doesn't match left square, we spit out, we throw the error. And then, okay. Well, the error went away now. So I think I've gotten everything I need for parsing now. I think. Ooh, I didn't like this one. Unreachable code. Good. Well, nice of you to tell me that. I'm happy to get rid of it if you don't want it. And I'm going to go test this. The way to test it is I've got to fire up the parser again. So that involves going over to the locks program. I'll leave the token spitting out just for the heck of it. And then I'll work out the parser. I'll get the parser to spit out as well using the AST printer. So I'm just putting that code back in. All right, I got to recompile my program. There it is. Happy. I got to rerun my program. I'll run it on Tiny. Okay, it said the thing that it parsed was a variance expression flow. That's because I cheated on my AST printer. Let's go back and adjust the AST printer just so I can see a bit more. Let's do what it suggested. Let's do the if all of them equals null. exp dot, we've got a mean equals null, and once I tell it that much, the Copilot makes a good decision, and I just scan all that to make sure it's made a good decision. Null equals variance equals null. Yep. If any of those equal null, then just return, well, I'm going to return a broken flow was parsed. Not really the right place to put an error, but that'll do for now. Otherwise, I'm going to return something that looks like a float. Square bracket, mean to string. Oh, thank you, Copilot. That's helpful. That's reversing the parsing for me, which is pretty much what I want to do. Thank you. So now I'm going to return like the actual, I'm going to put the form back out again so I can see it. So we're just going all the way through a parser just to spit back out the same form, but it's okay. We've got the AST in the middle, which was the whole point. Here we go. All right, it's parsed it correctly. 114, that's what Tiny was, right? 114. Okay, and it says 1.0 because it parsed it in as a double. Then I go for small. Okay, and remembering that the way the Pretty Printer prints out binary operators, it always does them in parentheses with the plus at the front. It's parsed that one correctly. Then I will go larger. Very good. An arrow operator is perfectly happily being picked up as a binary operator, separate to the plus operator. The parentheses are being picked up as a group. Nice. And finally, I'll check my last one. We got an error. Okay, so error at 2, expected tilde after mean. Let's go have a look if there's a problem in my Devlin's code. Okay. I can't see exactly where that is, can I? No, I can just see it's line 1, which is not very helpful. Okay, I think this is a problem in my parser because that looks okay. So it worked with larger, that was fine. And then it failed on Devlin's. So debugging, this is where debugging gets tricky. And so I'll do it with you because like I won't just go, oh, there must be an error and move on. Let's find out. So larger worked okay. Devlin's did not work. Just going to put larger on the same file in Devlin's. This obviously won't parse with this down here, but I'm just going to line all this up so that it works. Okay, this is me just looking at the structure. I'm laying this out so the structures match. Okay. So if I add that and that, I get one step closer to Devlin's. So I'm going to make a scratch file. And I'm going to take that example, which is getting me one step closer to Devlin's, and just pop it in there. It's not a real example for me to play with, so I don't want to give it a real name. Okay, it happily did that one. So now we jump to the next part, which is adding this in to see if this is the problem. Okay, so that lines up nicely there. That's still a valid term, so let's put that in the scratch file. Okay, error at 2, something after mean. Okay, we found the thing that's caused our error. It was the addition of this. 3 tilde 2 square bracket 8 is just fine with a plus after it. And then, whereas parsing this one was absolutely fine. Just go back and check that again. Okay, so that one parsed perfectly fine. You guys can probably see the error and I can't. 1 tilde 1 at 3 plus. Just trying a different. That one worked. So it's got something to do with the characters I've put in there, I think. So 3 tilde 2 at 8 was my problem. 3 tilde 2 at 8. And that's parsed just fine. And I'll try putting the extra spaces in to see if that's the problem, but I doubt it. It's not the extra spaces. Okay. One thing that's very possible to have happened is that one of these characters has turned out not to be it's some kind of weird Unicode character. So it was saying I wanted a tilde after a mean, and it was complaining on that one. So let's just rewrite my tildes and try Devlin's again. Error at 0, something expected after mean. I think all these tildes might have copied across as not being tildes. Yes, okay, so there we go. That was some strange debugging for you, but that kind of thing you do have to worry about in the Unicode world. Sometimes if I copy and paste a string from one place to another, the character that comes across is not exactly the tilde character. I'm just guessing here, but most likely. It's some Unicode character that looks just like the tilde character. And so my parser was complaining about it. So there wasn't actually an error in my parser. I just had to get the program correct. All right, well, there we go. We got our parser for the more complicated form. So this is, I'll say it again, I said it in the last one, this is not the simplest thing in the world, but it's also not the most complex. If you get your head around the machinery, you can pick your way through. And that's kind of the job of this course, is getting your head around the machinery. This is what it's like to work on a big code base that's not yours. That's what we're doing in this semester, and that's what programming life is all about, more and more than ever. And hopefully you've seen also the way that, at least for this task, I'm choosing to use Copilot. I don't use it as a chatbot that I ask questions to. Copilot is plugged into my IDE and making suggestions, but I am carefully checking every one of those suggestions before I include them. Copilot is generally saving me from typing and sometimes just reminding me of something I would have had to look up before I typed it. Okay, see you next time.